This is lesson 5-3B from the Algebra Readiness textbook. Work the following study guide problem in your notes packet on your own, and then continue the video when you're ready to compare your answer to mine. You are cutting vegetables for a party. You have 1/2 pound of carrots, 1/4 pound of broccoli, and 3/4 pounds of peppers. How many pounds of vegetables do you have in all? It looks to me like I'm being asked to add 1/2 plus 1/4 plus 3/4. I know that to add, I find a common denominator, and then I add the numerators and keep the denominators. My common denominator is 4. I only have to convert one of the fractions, 1/2, to having an equivalent fraction with a denominator of 4 by multiplying by 2/2. Now I'm going to add all of my numerators, and I get 6, and I keep the denominator of 4. Then I need to convert this because I have an improper fraction. So really, I am doing 6 divided by 4. Now, some of you do this in your head, so I'm going to draw my little think bubble because that's what's happening in your head. 4 goes into 6 one time. I subtract, I get 2, 1 and 2/4. Other people say, well, how many groups of 4 go into 6? One group. When I take out one group of 4 from 6, what am I left with? 2/4. So do you see how that's the thinking is the exact same answer? Then I divide or simplify by dividing by 2/2, and I get 1 and 1/2 and label it pounds. Yesterday, our learning target was to add fractions, and today's learning target is to work on subtracting fractions. Now, subtracting fractions has the exact same rules as adding fractions. So let's write these down. How do we add or subtract fractions? Step 1, convert to equivalent fractions with a common denominator. Step 2, subtract the numerators and keep the denominator. Now, if you have some that are negatives, that you have negative fractions in there, let's go back to converting subtraction to adding the opposite. In the example shown, I have 1/8 minus 5/6. This is also in your notes. I'm going to find a common denominator, in this case of 24. That means I need to multiply the first fraction by 3/3 and the second fraction by 4/4. 8 times 3 gave me 24. 3 times 1 is 3. 5 times 4 is 20, 20/4. So this is where I'm talking about 3/24 minus 20/24. Do you see that 3 is smaller than 20? So I need to think about this as this subtraction problem as adding the opposite. What do you do when you're adding two fractions and the first fraction is positive and the other fraction is negative? Well, you subtract the two numbers, putting the bigger one on top and giving the answer the sign of the problem with this, or of the fraction with the largest absolute value. So 20/24 minus 3/24 leaves me with 17/24. The largest absolute value is 20/24, and that's negative, so my answer to this problem is also negative. So we're reviewing those adding and subtracting negative rules. All right, the next problem. This should read 1/8 minus 5x/6. I'm going to convert this to adding the opposite. Then I'm going to write equivalent fractions with a denominator of 24. I multiply the first fraction by 3/3 and the second fraction by 4/4. 3 times 1 is 3. Then my second fraction, 5x times 4 is 20x. And what I'm left with is 3 minus 20x all over 24. And go ahead and leave that expression just as it is. 3 and 20x are not like terms, so you cannot combine them. The 3 does not have an x. Okay? The next one. 1/3 minus 1/4. The common denominator between 1/3 and 1/4 is 12. I multiply the first fraction by 4/4 and the second fraction by 3/3. Okay, now 4/12 minus 3/12. Because my first number is bigger, it's easy for me just to say 4 minus 3 is 1/12. If you're somebody who likes to convert all subtraction to adding the opposite, you'll see that 4 plus -3 is still 1, and then you keep the denominator the same, 1/12. All right, now it's time for you to try. The first problem here is 11/12, this is in your notes, minus 7/9. And then try 5, Okay, let's just try this one, 11/12 minus 7/9. All right, the common denominator between 12 and 9 is 36. To create an equivalent fraction, I multiply the first one by 3/3 and the second fraction by 4/4, and I get -28 here. Now I'm ready to solve. 33 plus -28, or 33 minus 28, is 5. And then I keep the denominator the same. My answer is positive because the number with the largest absolute value, 33/36, is positive. When you have a mixed number, I really like to stack them. 5 and 2/3 minus 3 and 1/6. Then I find a common denominator. 2/3, I multiply, the common denominator is 6, so 5 and 4/6 minus 3 and 1/6. 4 minus 1 is 3/6. 5 minus 3 is 2. 3/6 is not simplified, so when I simplify it, I get 2 and 1/2. Okay? Now, sometimes these mixed numbers get a little dicey. Let's try this one together. 11 and 3/5 minus 9 and 17/20. Watch what happens with this particular one. Let's put a star by this one so you know that this is a good example of one that gets a little tricky. When I find a common denominator, I multiply my numerator and denominator by 4. I rewrite my fraction as 11 and 12/20. And then my other fraction is still 9 and 17/20 and remains unchanged. Now, when I take 12 minus 17, I can't do it because 12 is smaller than 17. So what I have to do is borrow from my whole number. So instead of this being 11, I'm going to borrow 1 whole. And then I'm going to add that 1 whole to the fraction portion. because the top number still has to represent the same amount. So I just took the 1 and I added it, and I called it, when I added it, I called it 20 twentieths. I can rename 12 twentieths plus 20 twentieths as 32 twentieths in that box. So this all is 20 or 32 twentieths. Now I can subtract. 32 minus 17 gives me 15 twentieths. 10 minus 9 is 1. Then I simplify my fraction, and I get 1 3/4. Okay, so just to review one more time back what happened here. I had 11 3/5 minus 9 17 twentieths. This is where I started. I created an equivalent fraction, and I renamed 11 3/5 to be 11 12 twentieths. When I went to subtract 12 minus 17, I couldn't do it. Don't call that 5. That's a mistake. 12 is the bigger, or 12 is on the top, and that's supposed to be the bigger number. So I had to borrow from the 1, and that became a 0. The 1 I borrowed, I renamed over here. I can call any number over itself 1. So I used 20 twentieths, and I added it to 12 twentieths. That's how I got 32 twentieths. 32 twentieths minus 17 twentieths gave me 15 twentieths, and then I took 10 minus 9 and I got 1 3/4. All right, the next problem. Do you see in the next problem you have a negative number plus a negative number? What's the rule when you have two negative numbers and you are adding them together? Well, you're going more negative, aren't you? If the signs are the same, you add the two numbers and keep the sign. So, right now, everybody pause the video and try adding these two numbers and keeping your answer negative. Come on back to compare your answer to mine. All right, the first thing I needed to do was create equivalent fractions with a common denominator. This is where I got 1 8/12 and 2 3/12. Then I add 8 plus 3 and I get 11/12. 2 plus 1 is 3. And now that's not my final answer because I have a negative and a negative. So my answer is negative 3 and 11/12. All right. Carrying on. Pause the video and try the next two problems. Then come on back to compare your answer to mine. The first thing we need to do is rewrite the first fraction to have a common denominator of 20. So I get 2 14 twentieths minus, hold on, I got to stop here. Let's try that again. So I have 2 14 twentieths minus 3 7 twentieths. Do you see that this whole amount, 2 14 twentieths, is smaller than this one? So, and also I'm subtracting. So let's change subtracting to adding the opposite. Well, how do you add two numbers that have different signs? Well, we subtract them, and when you subtract them, you can put whichever one you want in the numerator. So 3 7 twentieths minus 2 14 twentieths. Now, 7 twentieths minus 14 twentieths, I can't do it because 7 is smaller. So I'm going to borrow 1 whole from the 3. I can call, I could write plus 1 here, but that doesn't help me. I'm going to call it plus 20 over 20 because of this 20 here. Now, I'm going to rename this amount. 7 plus 20 is 27 twentieths. 27 minus 14 is 3. So I get 13 twentieths. 2 minus 2 is 0. Then I need to ask myself, you give it the sign of the bigger absolute value. Well, 3 and 7 twentieths was the bigger absolute value. So your answer should be negative 13 twentieths. In the second problem, it's similar. 1 and 1/2 plus negative 2 and 4/5. So I subtract the numbers, but I'm going to put the larger one on the top, 2 and 4/5 minus 1 and 1/2. I rewrite the two fractions with a common denominator. The common denominator will be 10. So 1 and 5/10 and 2 and 8/10. 8 minus 5 is 3/10. 2 minus 1 is 1. The number with the larger absolute value is 2 and 4/5. It is negative, so my answer is also negative. So really, you're combining a lot of skills that you've learned both in 6th grade and in the first couple chapters of this year. This really does take a lot of practice, so I would like you to try the next two problems, and then by pausing the video. So try them independently, and then continue the video to compare your answers to mine. In this first problem, I have 7/30 and 29/75. If I multiply the first number by 2, the 75 by 2, I get 150. So I think that's going to be my least common multiple. Now, 5 times 30 is 150. 7 times 5 is 35. 29 times 2 gives me 58. 58. I changed subtraction to adding the opposite. Now I'm ready to go. I have two numbers. This is positive, this one is negative, and I'm adding. So I subtract the two numbers, putting the biggest one on top. Eight minus 5 is 3. 5 minus 3 is 2. 23 over 150. Then I give it the sign of the larger absolute value. In this case, 58 over 150 is bigger than 35 over 150, and it's negative. So my answer is negative 23 1/50ths. The last one for the day, I've got 5 and 6. The common denominator will be 30. I multiply this fraction by 5 over 5 and this fraction by 6 over 6. 6 times 2 is 12n over 30 plus 5 times 6 is 30. 5 times n is 5n. 12n minus 5n. Those are like terms because they are the same variable raised to the same power. So 12n minus 5n is 7n. And then keep the denominator the same. 7n over 30. And then the bigger absolute value is positive, so my answer is positive. All right, let's give this a try on a worksheet. The worksheet does not include any variables at all, so give that a try.